What is a set? A set is a clearly defined collection of distinct items which are usually connected by a common property. A set is denoted by a capital letter. Defining a set. A set is defined when the elements of that set are clearly specified. We can define a set by 1. Describing the elements of that set. So, for example, we could say that A is the set of vowels of the alphabet. All right, and the same we could also describe it by doing this, putting the curly brackets and say the set. Sorry, the curly brackets actually mean the set of, and then you just put between them vowels of the alphabet. All right. So both of these are saying, so here I'm defining as the set A by describing its elements. I can do it as though it's done at the top or as it's done at the bottom, which is to put in curly brackets, vowels of the alphabet. And the curly brackets themselves means the set of, and then the rest would be vowels of the alphabet. The second way we can define a set is that we can list the elements separated by commas enclosed in a pair of curly brackets. So I could say that A is the set A, E, I, O, and U. All right, some symbols used in set. All right, the first symbol, the symbol number 1, means is an element of. So using the set A above as an example, I could say that little a is an element of the set big A. Or I could say that E is an element of the set big A. So the first symbol means is an element of. The second symbol is not, means is not an element of. So I could say B is not an element of the set A. S is a symbol for the number of subsets. All right, so N and in brackets A is saying the number of elements in A. So again, using the symbol above as an example, I could say the number of elements in the set A is equal to 5. The number of elements in the set A is equal to 5. N is a symbol for the set of natural numbers. W, the set of whole numbers. Z, the set of integers. Q, the set of rational numbers. R, the set of real numbers. U is the symbol for the universal set. All right. The symbol here at 11 means is contained in or is a subset of. So the set A, which is the set we defined earlier, A, E, I, O, U. I could easily say that the set little a is a singleton set. I could say that this set is contained in or is a subset of the set A, E, I, O, and U. All right. 12, the curly brackets empty, and that circle or 0 with a stroke across it is a symbol for the null set. And at 13, the curly brackets X followed by a colon reads the set of all elements such that, all right, so that reads the set of all elements such that, all right, going up here, the end here is the symbol for intersect. All right, n at 14 is a symbol for intersect. So it's all like look like an upside down U. And the right side up U is a symbol for union. All right, so this could probably look something like this. It's a symbol for union. All right, and these two ideas will come across a little bit later from now. Finite and infinite set. A finite set is a set of which it is possible to list and count all its elements. A finite set is a set of which it is possible to list and count all its elements. So the set A, which is the set A, E, I, O, U, is a finite set because I can list all the elements and I can count them. Now, an infinite set is a set of which it is not possible to list or count all the elements. Now, the set of natural numbers n, start counting from 1, is an example of an infinite set because you could basically count forever. All right, you could count forever. Numbers go on forever. So the set of natural numbers is an infinite set. You can't list and you cannot count all its what elements. A singleton set. A singleton set is a set with only one element. For example, F is the set of months of the year with less than 30 days. So F is actually the set. The only element, the only month that is within that set would be February. So that is a singleton set. The null or empty set is a set that has no element. A null set is denoted by those curly brackets, empty curly brackets. It's a null set. Here are some examples of a null set. 1, the set of weeks of the year with 8 days. Well, everybody knows every week has what? 7 days. So there are no weeks in the year with 8 days. So the set of weeks with 8 days is a null set. P, number 2 says P is the set of all x such that x is an integer and x squared is less than 0. Well, less than 0, x squared being less than 0 is saying that x squared is negative, and that is impossible. If x is an integer, the square of an integer is always positive. So therefore, the set of all integers such that x squared is less than 0 is a null set. Number 3, the days with 30 hours. H is also a null set because every day only contains 24 hours. Equal sets. Two sets are equal if they have the exact same elements, irrespective of the order of those elements. Therefore, the set A, E, I, O, U, and the set V, E, U, O, A, I are equal sets. They're equal because they have the exact same elements. No more, no less. The order does not matter. Equivalent sets. Equivalent sets have the same number of elements. So two sets are equivalent if they have the same number of elements. All right, here's an example. Example 1, it says P is the set of factors of 15. Which of the following sets is equivalent to the set P? All right, so let's list the elements of the set P. So P is the set of factors of 15. So factors of 15 would be all numbers that can go into 15 without leaving a remainder. So 1, 3, 5, and 15 are elements of the set P. All right. Now, the number of elements in P is, you can count them 1, 2, 3, 4. P has 4 elements. So a set that is equivalent to P would also have what? 4 elements. Looking at the answers, the only one that fits that is C. So the set at C is equivalent to the set P, which is the set of factors of 15. Example 2. Sorry, number of subset. This simply says list the subset of P, of the set P, which has elements A, B, and C, and then we're asked to say how many elements does P have. Well, here A, the singleton set with just A in it is a subset. So a subset is basically a set that can be taken from a larger set. The singleton set with just B in it is a subset. This is also a subset. Now let's take them two at a time. So AB, that would be a subset. AC would also be a subset. And BC would also be a subset. So that's 6 so far. And the set A, B, C would also be a subset. And the null set would also be a subset. And so we're asked how many sets do we have? So the number of subsets S, so this is I. So the number of subsets S is equal to 8. All right. Please also observe that the null set is a subset of every set, and every set is a subset of itself. So the null set is a subset of every set, and every set is a subset of itself. Also, the set P, which has what? 3 elements, has a total of what? 8 subsets. All right. Now S, the number of subsets the number of subsets of a set is given by the formula S is equal to 2 to the n, where n is the number of elements in the set. All right, so there's a formula for calculating the number of subsets, and the formula is S, the number of subsets is equal to 2 to the n, where n in the formula stands for the number of elements. Example 3. Determine by calculation the number of subsets of the set P. All right, in the previous example, we already concluded that P has 8 subsets. So let us see if calculation will also agree. First of all, the number of elements in P is equal to 3. So the number of subsets of P would be equal to 2 to the third power. It's 2 to the n, where n represents the what? The number of subsets. 2 to the n means 2 times 2 times 2, which is 8. So a set that has 3 elements will have 8 subsets. Again, the formula for determining the number of subsets is S is equal to 2 to the n, where n is the number of elements. All right, let's talk about the universal set. The universal set is denoted by capital U, and it contains all elements. All other sets are subsets of the universal set. So in a given scenario, the universal set is a set that contains all the elements. The set with all the elements is the universal sets, and all other sets are subsets of the universal set. The Venn diagram. Now, a Venn diagram is a pictorial representation of the relationship among subsets of the universal set. In a Venn diagram, the universal set is represented by a rectangle, and a subset of the universal set is represented by a circle or an oval. All right, so let's just give a little sketch. So that's my universal set. And let us say that the set A is a subset of this universal set. All right, so the universal set is represented by a rectangle, and a subset is represented by a circle or an oval. All right, let's talk about complement of a set. Now, if ever you see something like this A here, and then there's that stroke or A prime, that stroke, it is what superscript A, that simple stroke there, or we could say A prime. In set, we would read that as um, the set A complement. We would read it as the set A complement, or just simply say A complement. Now, A complement is the set of all elements in the universal set which are not elements of set A. A complement is the set of all elements in the universal set which are not elements of set A. Now, if an element is not an element in set A, that element is automatically an element in the set A complement. Now let us see how would we represent or illustrate A complement on a Venn diagram. So let's illustrate a Venn diagram. Drawing everything freehand here, so might not be so perfect. All right, so there's a rectangle representing my universal set. Inside the universal set, I have, let's say, my set A. And so all the elements which are all elements which are elements of set A would be somewhere in this circle. So within this circle, this is the set A. It contains all elements which are members of the set what? A. Now, if an element is not an element in set A, that element is automatically an element of A complement. So for example here, X here, I could say that X is not an element of the set A. Now, if X is not an element of set A, X is automatically an element of the set A complement. So if in here is the set A, out here would be where you would have the set A complement. Ladies and gentlemen, A complement is the set of all elements in the universal set which are not in the set A. On a Venn diagram, that would be the entire area inside of the what rectangle that is not inside of A. Ladies and gentlemen, this unshaded area of the rectangle would be where you put elements of the set A complement. The unshaded area of the rectangle is represents the set A complement. All right, so things to remember from that. If an element is not an element of set A, that element is automatically an element in the set A complement. All right, let's have a look at example 4. Now, example 4. The universal set U is the set of natural numbers. So let's start out by listing the elements of U. I, A, or maybe we should read the question first. The universal set U is a set of natural numbers less than 11. A and A is a subset of U, and a subset of U, is the set of odd numbers. So I, using set notation, list the elements of the set U. So U is the set of counting numbers less than 11. So that would be like 1, 2. All right. So U is the set of counting numbers which are less than 11. Now B, the set A. The set A is the set of what? Of odd numbers. All right, since A is a subset of the universal set, I'm talking about odd numbers which are less than 11. All right, so just a little correction here. All right, since you say less than 11, it should not include 11. All right, so the odd numbers would be 1, 3, 4, 5. Ugh. All right, on a roll here, making mistakes. All right, 4 is not an odd number. 1, 3, 5, 7, and 9. All right, so next we are to list the elements of A complement. Now, what we said when we were defining A complement, we say that one, A complement is the set of all elements in the universal set which are not elements of the set A. So the elements would be like 2. So um, 2 is not in A, so it's in A complement. 4, 6, 8, and 10. So if you notice that the elements of A complement are all elements in the universal set which are not elements in or of set A. Note also that the elements of A and A complement together makes up the universal set. A and A complement together, added together, makes up the universal set. If an element is not in A, that element is automatically in A complement. All right, next we are asked to draw a Venn diagram of this information. Let's draw a Venn diagram of this information. So I have my universal set represented by a rectangle, U. Inside U, we have the set A. And inside A, we have 1, 3, 5, 7, and 9. Outside A, we have 2, 4, 6, 8, and 10. And we already conclude that in here is A, and out here is what? A complement. The region of the universal set that is not A is A complement. Inside the circle is A, and everything else within the rectangle is A complement. Lastly, I think we're asked to describe A complement. I could say that A complement is the set of all elements or all natural numbers which are less than 11. I could say that's one way I could say it. Or I could say the set of all natural numbers less than 11 which are not odd numbers. All right. Remember, A is what? A is odd numbers, so A complement would be all elements which are not odd numbers. I could also say that A complement is the set of even numbers less than 11. All right. A complement is the set of even numbers which are less than 11. All right. So that's the end of sets 1.